This is a video on constructors and destructors. A constructor is a class method that's automatically called when a class instance is created. And the purpose of a constructor is to initialize class properties. Remember, C and C++ do not initialize by default, so if you want it to happen, you must do it yourself, and a constructor is a vehicle to make that easier on the programmer. Constructor syntax. The constructor method name is the same name as the class. The constructor never has a return data type, although it may have parameters. The generic syntax is class name and then parentheses optional parameters for the declaration. For the definition, you have to prefix the class name again, so you have class name, class class name, optional parameters, then you assign your values. A specific example of that would be cdog for the declaration, and cdog : cdog open paren close paren for the definition. In the constructor, try not to access the class properties directly. So for example, don't do string copy and then the weight equals 0. Use the set methods instead. Set name to a blank string, set weight to 0. Why? Centralized business logic and boundary checking. It is way too easy to put in bad values or to have bad values passed in. But of course there is an exception to this rule, and that exception are pointers for dynamically allocated memory. Most set methods for pointers check to see if the pointer is non-zero, and if it is, delete the old memory before allocating new. Because pointers will most likely have a non-zero random value, they must be initialized to 0 in the constructors or in the initialize procedure before the set methods can be called. Otherwise, it'll try to free some random chunk of memory and cause you much pain and suffering. So that's why if you have, for example, the constructor for C resizable array, you must set the pointer to 0 and then call the set method. You can call the set method safely after that, because in the logic for that it'll check to see if the pointer is 0, and if it is, it won't do anything. It's very common to overload constructors to simulate optional parameters. So for example, we have our cdog.h file, and in there we have class cdog.h. We have probably some properties. Then we have what's called the default constructor, and then we have other constructors that take parameters. Normally you have constructors for the common parameters, and here, just for purposes of example, I have a parameterized constructor that takes a name and another one that takes a name and a weight. Also the constructor without any parameters is called the default constructor, and any constructor that takes a parameter is called, of course, a parameterized constructor. Another example for our C resizable array class, we could have a blank constructor. We could have one that takes an initial size, so it will automatically set the size, and we have another one that takes an initial size and a default value. So if, let's say, you don't want the default value to be 0, you could pass in maybe -1 or 42, something like that. And constructors are always the first methods declared and defined in both the source file and the header file. Now you can call the parent class constructor and a child class constructor and pass parameters to the parent class. The generic syntax is, and this is done in the definition, not the declaration, so in the source file, you have the child constructor, and let's say it takes 3 parameters, P1, P2, P3. I've left out the data types for simplicity. If you want to pass those parameters to the constructor of the parent class, you put colon and the parent class name that was inherited, and then any optional or any parameters in parentheses. Now, of course, there must be a parameterized constructor with matching number of parameters and data types. And then finally, since the third parameter is not part of the parent class, you would call the set method for that. So for example, we have ctrainDog that takes a name, and then it passes that name to our parent class dog constructor, and then it goes ahead and sets the breed, assuming breed is unique to ctrainDog. Now it's very cool, but I don't use that very often when coding it. I mention it here only for the sake of completeness. and I can't remember a single time when I've ever used that. Again, if you have a good business example of that, I'll put a bounty on it, a cup of coffee and or lunch, something like that, and we'll talk tech. Sometimes students ask which constructor gets called if there are multiple versions. The compiler will attempt to match the data types in the call with the declared parameterized constructors, and if it finds a match, it will use that one. If it can't find a match, it'll throw an error and you won't be able to compile. I find it efficient to make an initialize method that sets all the class properties and then call that from every constructor instead of calling the individual set methods. Why? Because it's very easy to forget to call initialize in a constructor, and that can cost you hours of debugging. If we were in the classroom environment right now, I'd ask for a volunteer to, when we get to some future homeworks, to forget to initialize your class properties in your constructor and to spend half an hour trying to debug that. One or two of you is going to volunteer even if you don't want to. So for example, here I make a here's the definition for initialize method for CDog, and it takes 1, 2, 3 parameters: a name, an age, and a weight. And if you'll notice, the name is by constant, so it can't be changed. And then I call the set methods for each of those. Then we'd call that initialize method from all of our dog constructors, and that would look something like this. So remember, there's no return data type for constructors. There's no return data type for constructors. Say it with me. There's no return data type for constructors. Somebody's going to put a void in there and spend half an hour trying to figure out how it won't compile. Alright, so in this first one, which is our default constructor, I call initialize with an empty string 0 and 0. And so I hard code blank or 0 values for defaults. In the next constructor, where I take just the name, I pass that on to initialize, but for age and weight, I hard code 0 values. For the next one, I get a name and an age. I pass those into initialize and 0. And finally, for the last constructor, I pass in all the parameters that I got with no hard-coded or blank values. In your code, you could call any of the class methods you needed. So for example, we could have CDog, CLSBuster1 with no parentheses. That would call the default constructor, and it assumes parentheses. You can put them in if you want. CLSBuster2 calls the second parameter, or the second constructor, which is the first parameterized constructor with just the name, and we get example 3 and 4. If I call bark for the first instance, I get yip 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 because the weight defaults to 1. If I call bark for the fourth instance, I get woof woof because 40 is definitely over 15 pounds. Let's take a look at that in code. I make an instance of CDog named Buster, and then I call my set methods, and to prove that those worked, I use get methods to print it out. Or I could call the initialize method that I created. Instead of calling the 3 individual set methods, I just make one call, which is a lot cleaner, and then I print those out, and I used slightly different values so you can see that it actually modified that. Or I can have another instance, but I call the parameterized constructor and print all that stuff out at once. So again, why do we use, here, let's write this out, why parameterized constructors? So that we can declare and initialize all in the same line of code. It borders on fancy code, but it is extremely useful in most of the time. So let's go ahead and run that and see what it looks like. And so I get Buster for my first one, which is exactly what it's supposed to. Then I get Super Buster with the modified values, and then I get the Super Buster with all its values. Didn't have to call any set methods or initialize. That was all done in the constructor. Now, it may not seem like a big deal to you now, but it will be. When we get to the final project, Superstring, you will have 8+ constructors. You have a constructor that takes nothing, one that takes character, one that takes a byte, one that takes a value, a short, and one that takes an int, and one that takes a float, and so on. Now, that's going to emulate VB's ability to do something like dim str buffer string equals a. Notice the single ticks, that means it's a character. It'll also take an integer, or it'll take a float. Now what happens right there is VB does an implicit cast for you to string. you are going to be writing the implicit cast code later on. And you'll find it's quite challenging. But that's good for you. You'll appreciate VB so much more, and you'll be a much stronger programmer. Let's talk about destructors. A destructor is a class method that's automatically called when a class instance is deleted or goes out of scope. And the purpose is to clean up. So constructor initializes, destructors clean up. So for example, you delete any dynamically allocated memory or close any open files. It is not called the deconstructor. It's called the destructor, not decon, but just destructor. You got to get that terminology right for when you're in an interview so that you sound professional, so that you can impress your would-be or potential employer. The destructor method name is the same name as the class, but with a tilde in front of it. The destructor never has a return data type, and it never takes parameters. So the generic syntax is class name, colon, tilde, class name, at least for the definition. So for example, we have cdog, tilde, cdog, parentheses. Now supposing if we dynamically allocated the name for a dog in the class, we would want to clean that up when it's deleted or goes out of scope, and so we would call delete and then set our pointer to zeros. Now destructors should be declared and defined immediately after constructors, and you never call the destructor directly. C++ does that for you. I find it efficient to make a cleanup method that clears all the class properties and then call that from the destructor. Why? Because sometimes you want to clear out everything in another class method, and it makes sense to have the same code in only one spot and call it from 2 or more places. It's just like clearform in the desk calculator project if you had that for me. You can call clearform from both the button clear click event and from the menu tools clear event. So for example, we have cdog, tilde cdog, we call cleanup, and then in the cleanup method we do whatever we have to. If you've got nothing to do, go ahead and write the destructor anyways and the cleanup method, and in the cleanup method put nothing to do. This is a placeholder for any future changes, and it provides a clear direction because in most projects you copy and paste for other classes as it grows, and you do not want it to evolve. You want it to follow in the direction that you laid out. So again, even if you're not dynamically allocating any memory, go ahead and put the destructor in and do the cleanup, and in the cleanup put nothing to do. The cleanup will take care of the problem of deleting any memory allocated in C resizable array when we are done using our instances. So for example, if we went to the last homework, we would automatically call initialize in our constructor and would set both the array size and the values to 0. You'd probably want to make initialize private after that, because if anyone else called it, you would lose your pointer to that hunk of memory that you allocated. So initialize would probably become private. Then in the destructor, you would call cleanup, and if your pointer is non-zero, you would delete it, set it to 0, and also set the size to 0. And that way you would make sure that you disposed of any memory that you dynamically allocated. Let's take a look at some constructors and destructors in code. So I have my cdog class, and here when I declare my methods, I have my 4 constructors first, and then I'm going to initialize. Now with initialize, I indent it slightly because it's used by the constructors. I would also want something equivalent for the destructor, which would go immediately after the constructors in the declarations, and I would indent cleanup to show that it's used by the destructor. So that's what the header file looks like. In the source file, I have got my default constructor calling initialize with the hard-coded blank values or 0 values for the parameters. I got 1 parameterized constructor, 2, and 3, and then there's my initialize method, which calls the set methods. And we do not access the class properties directly because that would bypass the centralized business logic and boundary checking. Then I've got the destructor immediately after the constructors, and we call cleanup. Now because, oops, and I got the wrong comment block, cleanup. Now, you could put initialize immediately after the first constructor, but I think it makes more sense to have all four of the constructors and then initialize after. Remember, it's the spirit of the law, not the letter, and then we put our destructor after the initialize and constructors. I'd like to point something out here. We have 1, 2, 3, 4 constructors. Oops, wait. Here, 1, 2, 3. Oh, only 3 constructors. There should be 4. Oh yeah, there's 4. Those are 4 different procedures, and they are all distinct, which means each one gets its own comment block. What I often see students do in code is this. They put all 4 procedures and then constructors, and then they mangle the comment block. They just do that. That isn't the coding standards. That's not what I asked. That's not what I wanted. Which procedures get comment blocks? The important ones. Which ones are important? All of them. If it's not important, delete it. So every constructor, yes, every single one, gets a comment block. In summary, a constructor is a class method that's automatically called when an instance is created, and the purpose is to initialize class properties. A destructor is a class method that's automatically called when a class instance is deleted or goes out of scope, and the purpose is to clean up, for example, delete any dynamically allocated memory. And overloading is very common with constructors.